So firstly, we're going to look at the principle of conservation of energy. Now this principle states that energy cannot be created nor destroyed, only transferred from one form to another. It is transferred in various ways, including by heating and waves. There are 5 main groups of energy stores. Number 1. Kinetic energy, which is stored in a moving object. Number 2. Chemical energy is stored in food and chemicals and batteries. Number 3. Elastic potential energy will be stored in object if it's changed from original shape. Number 4. Thermal energy, which is the energy of a substance due to the temperature of it. And finally we have number 5. Gravitational potential energy. This is stored in objects when they are above the ground. Energy can only be transferred from one form to another. For example, an object will have full kinetic energy and zero gravitational potential energy the instant it is thrown from the ground. As it travels upwards, it becomes slower, losing kinetic energy but gaining gravitational potential energy. This means at the top of its journey, the object will have zero kinetic energy store and maximum gravitational potential energy store. The kinetic energy is being transferred to gravitational potential energy. This conservation of energy is a very important principle and applies to all closed systems. A system is an object or a group of objects. A closed system will always have the same amount of energy at the start and at the end. This happens because the energy at the start is transferred into different stores within the system. In order to help you understand closed systems, we're going to look at some examples. Firstly, the pendulum. Imagine you're pulling a bob on a string towards you. At maximum height, the object has maximum gravitational potential energy store and zero kinetic energy store. As you let it go, it will move towards the equilibrium position, or the middle. As this happens, it gains kinetic energy store and loses gravitational potential energy store. This is because the gravitational potential energy store is transferred into kinetic energy store. The bob then loses kinetic energy store and gains gravitational potential energy store as it moves past the equilibrium position. The bob reaches nearly the same height due to the air resistance being very small. A more complex system is our second example. A mass on a string is released to the lowest point and then the spring jumps back up. When the mass is released, the spring is not stressed, so no elastic potential energy store is here yet. The kinetic energy store increases as it accelerates down and loses gravitational potential energy. The spring stretches, reducing the speed of the mass, therefore reducing the mass's kinetic energy store. The spring's elastic potential energy store increases due to its stretch. At the lowest point, the mass stops. All of the kinetic energy store it once had is now in the form of elastic potential energy store. The spring now recoils and the elastic potential energy store decreases as the kinetic energy store increases. When the spring returns to the original length again, the elastic potential energy store is 0 and the kinetic energy store is also 0 at the top. Work done and energy transferred are directly connected. When you apply a force to move an object, you are doing work. The work done is a transfer of energy. The amount of energy transferred to the object is equal to the work done on it. Therefore, energy transferred equals work done. The work done by force depends upon the size of the force and the distance it has travelled. This gives us the equation: work done measured in joules with the symbol W equals the force applied in newtons with the symbol F multiplied by the distance moved along the line of action of the force measured in meters with the symbol S. For example, if an object is pushed 10 meters by a force of 20 newtons, the work done is 20 times 10, which equals 200 joules. Now I'm going to introduce friction. Without friction, every surface would be too slippery for any one object to stay still on it. The work done to move an object must first overcome the friction that the surface is moving along holds against the object. This work done is transferred as thermal energy stores by heating.